Okay, I think it's start recording now. We need more cats photo. Like, I think this picture is a little like catfish. I'm not sure because like today I bring her to the vet, this one, and she's mad. She was mad at me. I couldn't put her into the carrier because she's too big and I cannot push her in. I just have to bring her with a leash, and she's upset with that. Okay, let's start the tutorial today. We will go over review a bit. So last tutorial, we ended with z-score. So the formula for z-score is z equal to x minus mean divided by standard deviation. So this one is the mean, and this one is standard deviation. So what does z-score tell us? It tells us the number of standard deviation that a data is away from the mean. And about visualization, you can think of it like this one. So it doesn't have to be symmetric. So let's say you have a distribution with mean equal to 0 and standard deviation is equal to 1. Something like this. So this one represents for like the distribution that you calculate z-score. And this one is the distribution for x. So this one is the mean, and this is the first standard deviation. This second standard deviation. And again, what this formula tells us is that, let's say you have a point, I want purple. Okay, let's say you have a point x in this. Then we want to know how many standard deviation that this point is away from the mean. The mean is this part here. So we will take the value of this x. We calculate the distance of x from the mean and then divide it by the standard deviation of our distribution. And this one tells us the number of standard deviation from the mean. You can also think that when you do this, when you calculate this number, it tells you the position of x. But in this graph, where the mean is 0 and standard deviation is 1. So like, it's kind of tell you, if you have this point with the distribution mean equal to this and standard deviation equal to this, then where is this point belong to in this graph? And it is helpful to compare, let's say you have two numbers from two different distribution that you will see later in exercise 1, and you want to kind of compare the relative position of that two observation compared to the mean. So it will be clearer when we start exercise 1. But what you need to remember now is the formula for z-score. The second thing we will talk in today's tutorial is about box plot. So box plot, it will look something like this. I don't know why it looks so ugly. But yeah, so basically the line here, the line in the middle of the box, it represents for the median. And the ending here, it is the first quartile. And this one means that it is above 25% of the data. And the one here is third quartile, so it is above 75% of the data. And again, the median is just about 50% of the data. Because median is the point in the middle. My cat name is Rosie. This one, I don't know, her name is kind of weird because her previous owner gave me this name, but then when I bring her to the vet, they always write her name like this. But I think they pronounce the same. Okay, so back to box plot. So if you have the box plot like this and you don't see anything in this part, if you don't see anything outside those two whisker end, so this one is whiskers, this one is also whiskers. So if you don't see any data outside the whiskers, then these two whiskers represent for the mean and max. Okay, so this is the maximum of your data, this is the minimum of your data. This is first quartile, this is third quartile, and this is the median. However, sometimes you will encounter the box plot. I think in the textbook, it will use the star like this. You might see something like this. And these are called outliers. And when you see outliers, then these two whiskers, it is not necessarily be the minimum and the maximum anymore. And it have a formula for that. So this one, when there is outlier, then this one here, it represents the first quartile minus 1.5 IQR. And here it is not maximum anymore, but it is the third quartile plus 1.5 IQR. And you calculate IQR by taking the first quartile minus the first quartile. So again, if you don't see any outlier, like if they do not exist, then this is your minimum, this is your maximum. However, if you see outlier, then the minimum and maximum are not this point anymore. Yeah, I can repeat that. So again, if you don't have any outlier in your data, so everything is falling within this part, then this one represents the minimum, this one represents the maximum. However, if you see outliers in your data, then this point, this one correspond to Q1 minus 1.5 IQR, and this one here is Q3 plus 1.5 IQR, which means that the maximum point for these two, it is this one. So this one, the maximum of it is this, and this whiskers end, the max for the minimum is this part. So if your minimum and maximum fall within this range, then these two whiskers will be your minimum and maximum. But if you see outliers, then these two whiskers corresponding to these two values, and you can calculate IQR by Q3 minus Q1. IQR is always Q3 minus Q1. Any other questions? Okay, and why do we introduce these score and box plot for you today? Because they are the two methods to detect outliers. So the first one, if you use Z-score, And if the absolute value of your z-score is between 2 and 3, so if it's between 2 and 3, then you call it possible outlier. And if it is greater than or equal to 3, then it is outliers. And if you use box plot, then any data that belong to, let's see, so Q3 plus 1.5 IQR and Q1 minus 1.5 IQR. Anything that is greater than this or smaller than this, we call them outliers, which means that any point that is not within these two whiskers, so everything inside these two whiskers are good, but outside these two whiskers, we call them outliers. Any question here? Okay, if not, then we will move to exercise 1. This week I create the like dark color, I think dark color background. So I posted it on Quarkus. If you want, you can download it. I also posted the white version as well. I don't know which one you prefer, but you can email me if you want other color as well. I can change it. So let's look at the first exercise. I will give you maybe 3 minutes to attempt it. So I take it out at 6:27. If you are done, you can actually write on the screen so me or your friends, your classmate can see your answer. We can discuss about it. Was it more than or absolute value of z? No. So the z-score, it is different. Z-score, you will get the actual number. Like you will get it probably like within this range most of the time. However, if the absolute value of your z-score is like, if your z-score fall between this area, then it is called possible outlier. Then what goes before the arrows? Which arrow? This one. Oh, this one is for box plot. Sorry. This one. So the thing here is the rule when you use box plot to detect outliers. And this one is a rule if you use z-score to detect outliers. There are two methods to detect outliers. Is a bigger the z-score, the bigger the score in the test? That's good question. So the answer for this is yes. We will also look at it and see why it happened. But if you figure out the z-score and you figure out the answer, feel free to write on your screen. But there is the button annotate. Anyone got the answer? Yes, the recording of this tutorial will be posted. Probably like by tonight after the last tutorials. Can someone give me the answer for exercise 1? What mean are we looking at? Yep, so that's a good question. We got the mean for LSAT and we got the mean for MCAT. It depends on which z-score you are trying to calculate. If you are looking for z-score for LSAT, then you should use the mean belong to LSAT. And if you're looking for the z-score for the score on MCAT, then you should use a mean of MCAT. No, we haven't discussed yet. I'm waiting for someone to give me some answer, just to make sure everyone know that what I was talking about. She did better in LSAT. How do you know that? The bigger z-score compared to, see, the bigger z-score compared to her MCAT. Yeah, that makes sense. Okay, I see some expression to calculate the distance from the mean. That's also in right direction. Yeah, that is a correct z-score. So in order to figure out which test she did relatively better on, you have to calculate the z-score for each test. So let's see here. So for LSAT, we have mean is 151 and standard deviation is 10. LSAT, we have mean is 151, standard deviation is 10. For MCAT, we have mean is 25.1 and standard deviation is 6.4. She scored 172 on LSAT, which means for LSAT, the X is 172. And for MCAT, she scored 37. So X in MCAT is 37. So first, you have to calculate the z-score for LSAT. You take X minus mean divided by standard deviation, which is 172 minus 151 divided by 10, and you will get 2.1. And what it is saying is that if you have mean of 0 and standard deviation of 1, then the position of her LSAT is in this part. So this one is the position for her LSAT. And if we calculate the MCAT, also X minus mean divided by standard deviation, 37 minus 25.1 divided by 6.4, we would have 1.86, which is, it is in this part MCAT. And how should we interpret this score? So for this one, if she is in this position, which means that her grade is better than people who got grade in this position. And her LSAT is here, which means that her LSAT is 2.1 standard deviation from the mean, which means she did better than people who received D score in this area. So here it is further from the mean than here. So you can kind of think of, I will not give exact number, but it's just example. You can think of this as she's in the top 5%, and this one is kind of similar to she's in the top 10%. So obviously this one is better, right? Does that make sense? I only see 2 yes. Can I see more if you understand? If not, then you can ask in the chat. I will explain again. Okay, that's good. So since the z-score for LSAT is greater than the z-score for MCAD, she did better on LSAT. Okay. So for exercise 2, again, I will give you 3 minutes to think. I will take this up at 3:37. If you have any question, feel free to type in the chat. Oh, yes, sorry. I really need some sleep these days. Oh my God, you don't know. I have 5 midterm this week. I'm taking 6 courses this semester, and 5 courses have midterm. Like, I don't know what I'm doing with my life. I have one statistics test tomorrow, and probably I might have to stay up tonight to study for it because I feel so nervous. Thank you. Hopefully I will do great. Like, I want to study, but then I have to TA a lot today, and then I have to bring the cat to vet as well because she was having some acne on her chin and it just looks so hurt. So I don't want to wait any longer because it might get worse. So I still have to manage to bring her to the vet, and it takes a while. I also thought that maybe I can bring her on my shoulder and walk to the vet. Yeah, Rosie, because like it's only 10 minutes walk from my place. It's on literally the same street. But then she was so heavy. And like when I first walk on the street, everyone's looking at her. So I decided to just take Uber. Like it's expensive for that small distance. But then again, she's too heavy for me. Yeah, she's chill. She just like eating, sleeping. She doesn't she doesn't like playing much. Like she is not active compared to the small cat that I have. Most of the time if I see her, she's either on my bed or she's on the sofa. She doesn't like walking around. Okay, let's look at this exercise. So what is the median of this data set based on this box plot? 4, yes. So the median we can find by the middle line in the box plot. And this one is correspond to 4. So median is 4. What is the upper and lower quartiles? 6 and 3. Yes, that's correct. So this one here, it is the upper quartile, and lower it is 1, so it looks like 3. They just tell us to approximate, so it is 6 and 3. Let me write clearer. So the upper is 6 and lower is 3. What is the IQR of the data set? How do you get 3? 16? Yeah, again, so IQR equal to third quartile minus first quartile. And this one, it is just the upper end here, so it is 6. And Q1 is actually the lower quartile, which is this one. So it is 3. So 6 minus 3 is 3. It is IQR. Does it make sense? Okay, thank you. Is the data set skewed to the left or skewed to the right or symmetric? What do you think? Left? Anyone else? Left, right? Okay, it's always good to have different opinions, so that we can discuss. So for box plot, if the data is symmetric, you should expect the median to be in the middle of the box plot. And these two whiskers is also having the same length. So this one is symmetric. And it looks like this graph, which means like mean and median is at the same point. If it looks something like this, so the median is more to the right. And this distance is longer than this one, which is just like the distance from this point to the median is more than the distance from median to this point. And this one is left skewed. It will look like this. So they kind of represent the same information. Is because the mean, it will be pulled toward this side. And when mean is less than median, we know that it is left skewed. We discussed this when we talk about histogram, I think. And the third situation is something like this. So the distance from mean to this point is larger than the distance from, the median to this point. And then the median is also more toward the left. Then this one is right skewed. And it'll look like this graph. Because it just have some unusual large data here that pull the mean to the right. And then when mean is greater than median, we know that it is right skewed. You think it's zoom in? I don't think so because I use like different page. So this one, I think it looks better. I think it just looks bigger for everyone because this one is using like same page, sorry, different page. And like here we can also see there's some extremely large value because there's some outlier to the right, which means there's some extremely large value, and it will pull the mean toward the right. And then again, mean is greater than median, so it looks like this. So this one is right skewed. What percentage of measurement lie to the right of median and to the left of upper quartile? Which means like what percentile of data to the right of median, which is like this part, and then to the left of upper quartile, which is this part. And when they intersect, it's just the box here, 25%. How do you know that? Median is 50, upper quartile is 75. Yeah, that's correct. So we know that the median is above 50% of data, and is also below 50% of data because it is just right in the middle, right? And then the upper quartile, it is above 75% of the data and is below 25% of the data. So here you can see that this part is 75% of the data. Sorry, this part is 75%. And the median is above 50%, but it is also below 50%. So this part here is 50% because the median is above 50% of the data. The upper quartile is above 75% of the data. Sorry, I still open study with me. I'm not sure if you can hear that sound. So yeah, if you take 75 minus 50, then you will get this part, which is 75 minus 50 equal to 25%. Is 75% minus 50% equal 25%. And identify any outliers in the data. What is the outliers? What is a word under median? Which part? This one is upper quartile, sorry. I will write as Q3. There's two. Do not cause confusion to you. So outliers are 12, 13, and 16, yes. So we have 12, 13, and 16, and I know it by looking at these 3 stars. They are outliers. So the first one corresponding to 12, the second one is between 12 and 14, so we just guess it's 13. And this one is in the position of 16. Any question about this exercise? Okay, if not, then we will move to exercise 3. is the last exercise for today. I will give you 3 minutes. So 6:50. Do you have any preference for the background color of the worksheet? Okay, I think no one care about it. Like, I was changing for a bit because I just feel bored looking at the white paper over and over again. I like white. Okay, there will be the white version for sure because I think it is the standard one. Like on screen. Yeah, I actually set every background color of my apps to black because I just feel white is a bit too bright for me. When the background is black, it gives me impression that the questions are harder. Did you look at our Quarkus page? It must be a super difficult course with that reasoning. I see. Like, it's so special. Like, it's the first course I saw that. I prefer white for presentations. Okay, let's look at this question. So, a manufacturer inbox containing 50 items, blah, blah, blah. So he say that on average, the box contained 4 defective items, and then someone verify and found that the box that they got contains 8 defective items, and we have standard deviation for number of defective items for box is 1.5, and they ask us to calculate the z-score. So we have standard deviation of number of defective items per box is 1.5, and he also claimed that the average number of defective items per box equal to 4. So this one is our mean, this one is our standard deviation, and we have x is equal to 8, which is the number of defective items that someone wants to verify and got it. So the z-score for this will be x minus mean divided by standard deviation. So 8 minus 4 divided by 1.5. What it is? I don't have calculator. 2.67, thank you. So 2.67. So they ask that consider your answer to part A. Do you have any reason to believe that the manufacturer's claim is correct? So here they are asking us to use the z-score to check like for outlier. So as we discussed, if absolute value of z fall between 2 and 3, then it is possible outliers. Which means that we can still believe that the manufacturer claim is correct, and we can just think that x equal to 8 is some outlier, like possible outliers, higher than usual mean. However, if you look at part C, they ask that what would be our answer if the standard deviation is 1.25 instead of 1.5? Then if we calculate z-score at this point, again, x minus mean divided by standard deviation. So 8 minus 4 divided by 1.25, what is this? Anyone have calculator? 3.2, yes. And we also talk that if the absolute value of z is greater than 3, then it outliers. So at this point, I doubt that the manufacturer claim is correct, because if the standard deviation is 1.25, then this 8 is too unlikely to happen, because like it's really, really far from the mean. Because if we look at the distribution, so these mean is first standard deviation, second, and then the third one, and it lies somewhere here, like it's really have a low chance to happen. So at this point, I started to doubt the manufacturer claim, and we will learn about this more in detail in the end of the course. I think not end, but maybe near the end, when we learn about hypothesis testing, then we will have a more formal answer for this one. So for part B, we can still believe the manufacturer's claim because the z-score is between 2 and 3. So it is possible outliers, which is like the chance that it happen is low, but is not as low as when z absolute value is greater than 3. Does it make sense? Any question? Okay. So what if it is exactly 3? I would say we still doubt the claim. Yeah, like if z's absolute value of z is greater than or equal to 3, then we started to doubt that claim. And why does that happen? We will learn more formally when we talk about hypothesis testing. So on Quarkus, you might find the, what does it call? The R code for this week. It is so short, so I will go over it quickly. Let's see. Yeah, so if you scroll down to the tutorial, has the post anything about makeup lecture? I'm not sure about that. But good thing is we are not behind lecture, so hopefully you can be prepared for any quiz or test. So yeah, you can download the tutorial 4.r to your computer and then upload it to Jupyter Hub, like U of T Jupyter, I think. And there is one special thing about the code today. Where is that? Yeah. So please put it in the same folder with the R code that you have in other tutorials and also the data file. So in the other tutorial, we often do like read.csv to read some data from the CSV file. However, we will not use that code today. What you can do is this one. If you click this data and you can choose import data set, they will show up in your global environment here, and you can refer to this table because the read.csv method, so many students have trouble with the path to open it. That's why we want to introduce this today. You can click on the CSV file and click import dataset. Then it will import it in here. And this is the name of the variable that store the data. And if you run the first line here, what it show you is just the table that you import. For the second line, what it's saying is that I want to copy the data from this table to a variable named height. Just because we don't want to type all these long titles every time we want to access to the table data. That's why we set this table equal to this variable. So all the information that's stored in this table now will be stored in this variable. So if you run this, you will get this variable in the global environment. And if you click this, it just gives you the same data in this table. So it's the same data, but now it has shorter name. It's like nickname. So you don't have to type all these long thing whenever you want to use the table. So the third line, what it's saying is that I want to generate a box plot. So you call box plot and put some argument inside. What it's saying is that I want to generate a box plot from the data of this table. So table height and column is male height in centimeter. So this dollar sign is to separate the table name and the column name. And this one is just the title of the box plot. And this one is setting the box plot color to some color that you want. So if you run this, the box plot will be shown in your bottom right corner. And if you run the fourth line, it will show you the box plot of the column female height in centimeter. And the data is from the height table. And main equal to something is just the name of the box plot. And this one is the color of the box plot. So if we run this, we would get this one. And again, this command is to find the mean, which is the average of male height in centimeter. This one is the mean for female height. And we also get to know the summary statistic, which show us, let's see. So we have the minimum, the maximum, the first quartile, the third quartile, the median, and the mean. So it is exactly corresponding to this box plot. So we have mean here, maximum here. This one, this line in the middle of the box plot is a median. This one here is the third quartile, and this one is the first quartile. So that's how you generate a box plot. Any question here? If not, then you can go. It's the end of the today tutorial. If you have any question, feel free to stop at my office hour in 2 weeks. Next week is reading week, so I will not have office hour and we will also not have tutorials. And have a good night, everyone.